Okay, everybody. I want to wish you guys a good morning. Hope you guys are well. Just trying to find a few things here in our book because I do like a few kind of questions. We're going to talk again, go through some more examples of, testing about a proportion. And this is going to be probably focus more on the health related kind of questions, right? But not necessarily. So let's look at some more examples. Okay, let's get back to these kind of things. So, all right. So let's go here to the iPad. Yeah, we could look at something like this. Well, how about if I kind of make up one example for now? Because I want to talk about some details. How about something like this? We'll compare and contrast, and we'll get to some more. I want to at least talk about this. How about if we say, who's smarter? Well, I guess that's not it's a bad way of phrasing it. Not who's smarter. How about if someone, Snodgrass, here's Professor Snodgrass again. Professor Snodgrass claims that women are more likely to pass Math 227 than men. Such an explosive claim. And then it says a sample of 120 women reveal that 85 pass, and a sample of 150 men reveal that 82 pass. Use the 5% level of significance to test this claim. Okay, a very, very, very explosive kind of statement. However, this is actually, what people look at, ladies and gentlemen. These are kind of issues that people kind of ponder and want to investigate, whether it's in a social science setting, a medical setting, a political science setting, these are the kind of things that people look at. They look at demographics, and we're going to compare two groups here now. And you say, well, who are we really comparing? Well, women versus who? Men. We compare two groups, and that's what we did yesterday. And again, also, what's the parameter here in which we use? Right? When they say women are, here's a key phrase, more likely. And I actually gave you guys this definition a long time ago. When we've been looking at a lot of probabilities, it was a definition associated with probabilities, more likely. So what you guys want to know is that when you're talking likelihood, that's probability. And more importantly, the claim is about a proportion, because that's a proportion. The word proportion is analogous to, or it really means probability or percent. But probabilities are percents and vice versa. You just move the decimal. So don't think P stands for population. It doesn't. It just stands for proportion, which is a more general way to say probability or percent, ratio, fraction. So when they say the probability of women, because I want to do this, I want to remind you guys, we have to write down the claim. That's an important detail. The proportion of women versus the proportion of men. Those are the two groups. All right, so let's ask you guys here. You have to write down the claim, because like I said, this is a hypothesis testing question. They say, test the claim. So tell me what's going on with this. Do you guys know? What do they mean? How do I describe this relationship that the proportion of women, proportion of men, how do we say more likely? What's the inequality symbol? Because this is where it starts. You see, whenever I ask a test or ask a question on hypothesis testing on a test, my first question is, what is the claim? And you have to write that claim down symbolically. So being more likely means you have a greater chance, meaning it's the greater than sign. Being more likely, greater than. Being less likely is less than. So like you guys see here, there's some hidden language at times. And people say, I don't see a P. You're not telling me. It's like, no, you got to read that and think about that, right? More likelihood applies to parameter of probability. So there's your P. Okay. There you guys go. So here's your claim. We know what that is. Now pay attention to this, because some people might still be, have an issue about how to draw a conclusion. You see, because ladies and gentlemen, you're going to test this claim. You're testing what the person is saying. And so that's why I label it claim. But the next step would be, where does that belong? That belongs as an alternate hypothesis. That belongs here. And it belongs there because it does not have a condition of equality. And again, I put the word claim there. It's very helpful for me. And remember, we have to write down the opposite. Okay? So the opposite of that greater than is less than or equal. So we just set up our hypothesis. All right? You guys okay with that? So that's the key phrase that we have to be careful with. So I wanted to write it down in a way that, people communicate, because people say that. They don't say the probability of women is greater than the probability of men. I mean, they can, but they kind of a little bit more, I should say, conversational about it, right? They might say, hey, it's more likely that you pass if you're a woman than a man. And in fact, some sort of dark data that's coming out, that it's more likely, that there's a greater probability of men biting the dust, I guess, when it comes to COVID-19 than women. And they're measuring chance. That's probability. It's a ratio. It's a fraction. So the men have to worry. Well, we all do, but you guys get the picture. So this is kind of stuff that you do read about in terms of probability. They're talking chance. All righty. Here we go. So this is where you start. What kind of, or I should say, you look at, again, the alternate hypothesis, and since it's greater than, that means we have a right tail test. So we draw our normal distribution. We need a right tail now. Here's a right tail. This is a do not reject the null. And this is a reject the null. You have a critical value. So you might say, well, how do I find if it's this is a right tail? It's pointing to the right. That greater than sign, that's what you look at. That's why I put this eyeball. That's an eyeball. Alrighty. So you might say, I need a level of significance. Well, you have one. 5% level of significance. And we're going to give you some definitions of that. 5%. So if that's 5%, we know when we look at the Z table, we need 45%. And let's get rid of this. We need 45%. And you say, oh, okay, we're looking for 45%. It would be right here. There's an arrow there. And it says for area being 45% down here, it's pointing to 45%. Ah, you use a Z-score of 1.645. Okay. So again, we're going to actually require a test statistic. And the test statistic formula from yesterday is sample proportion 1 minus sample proportion 2 divided by square root of p squiggle minus p squiggle over n1 plus p squiggle over 1 minus p squiggle over n2. And I'm going to write it a little bit because it is kind of difficult to write like that, right? I'm going to make that in the center here. So this is our test statistic, but we need this thing, which is your pooled POO, a pooled proportion, meaning to pool your resources means to put together. So we're going to need successes, the total number of successes, and the total number in the samples. And then after that, we have the complement of such, which is 1 minus p. So if you want, in your particular notes, in your formula sheet, you can put that as Q even. So this is where we're at. And so what was different from today that you have is the sample information. And you say, what do you mean? Well, a sample of 120 women. So my first group here, this is N, 120 women reveal that 85 passed. Those are successes. So this is an X value. So what I do here is I write this down. Women, okay, N1, that's my first group. 120 women had 85 successes. And since we're on the topic, let's find out what's that as a proportion. 85 over 120, that's the rate. So we find the TI and say, okay, TI 85 divided by 120. And we're going to go out here to the thousands. 0.708 to the thousands. So this is like saying 70.8% of women pass Math 227. That's a sample proportion. So we know this goes here, ladies and gentlemen. 0.708, and N1 is 120. And since we're on the topic here, we can say N1 is 120, and the successes here is 85 there. So we're going to plug in these values here. Now, the next set of information for sample is about min. So I need N2, I need X2. Then, of course, we're going to compute the sample proportion for min. So this is how it's different. Yesterday, they gave us the percent when we went through those details. Today, they give us successes. So they're saying a sample of 150 min. So this is N. Reveal that 82 pass. And that's going to be X. So 150, 82, 82 out of 150. We need that sample proportion. 82 out of 150. So we get 82 divided by 150. And we get 0.547 if we round to the nearest thousandths. So that's about 54.7%. Okay? So here's kind of how you look at some of these things here. And this is for the min now. That's a separate category. It's a separate group. We're comparing proportions here. So now let's plug in those values in our formula. And you might say, okay, 0.547 here. And this was out of 150 guys. And we have here 82 successes out of 150. And so, ladies and gentlemen, we're on our way to plugging in all these values. We just need to find here, and I'll label this the what? Pooled proportion that goes here and here. And then we need that complement of the pooled proportion. And you say, how do I get the pooled, P-O-O-L-E-D, the pooled proportion? Add the total number of successes, X1 plus X2, add 85 and 82, and add the total sample sizes, 120 and 150, and you're going to get that result. So if I say TI calculator, put a parenthesis here, and you have the information above. That's 85 plus 82, and then you close that. Because you're telling the calculator you have a numerator that's a sum, divided by a denominator that's a sum. And you say, what's that? 120 plus 150. And you close that. And now you get a pooled proportion value. Round to the same place. Right? We're going to be consistent. You're going to round this to the nearest thousandths. So the pooled proportion is approximately going to be 0.61. That makes this a 9. Now, the complement of this, right, is when I take 1 minus 0.619. This is the complement, and that's 0.381. Okay, so this is how you go about finding these values. And if I go to the iPad, I wrote those down. Let's double check. The pooled proportion is 0.619. Its complement is 0.381. So that goes here and over here. So we say 0.619 times 0.381. This is 0.619 times 0.381. And so you have all the information you need, ladies and gentlemen, to plug this in your TI. Or, sorry, any other calculator you have. So let's write this down, because I have to write it down again, personally. I think that's a good practice. But be careful whenever you rewrite anything. Make sure you don't make a mistake when you rewrite it. So I got 708,547. So I do this for clarity for students. And then you have 0.619, 0.381. Out of 120. 0.619 times 0.381 out of 150. And yeah, all right, whatever. Let me make that smaller then because it looks a little weird. So here's my point to you guys. When you use this information in your calculator, and double check, right? I want to check that 708. Yeah, we have it here, 547. And then we have 0.619, 0.381, 120, and 150. Okay, double check this because you have here in the numerator parentheses. Because remember, you have to tell the calculator, hey, this is a numerator because you're going to be dividing by a radical. And then when you use that square root now. So let me go back here. Let's start to do this by the TI. And I'll clear that. Remember, I'm saying put the parentheses 0.708 minus 0.547. You're going to close that, and then you're going to divide by a radical. There you go. You start by opening that parentheses. Now, if your calculator does that automatically, good for you. And now I'm going to say you have to enter, to go through the details, this arithmetic right here. So you need a second set of parentheses. And that's why when I enter that, I open another parentheses to say I have a product of 0.619 with 0.381 divided by 120. And then I close that parentheses. Don't forget to what? Add. You say, why do I add? Because what we have to do now is tell the calculator, I have another set of computation here to do right here. Because I'm adding with another set. So you have to add another set of parentheses right in here. And so with the TI, you'll see that I put, okay, open and tell the calculator to take 0.619 times 0.381, and then you divide by 150. And you close that because that's the computation you have to do. And don't forget that you're going to have to, again, put another parentheses. And then people say, why? Because you're telling the calculator originally that everything between those two red marks applies to that original radical. And that's how this works. So be sure then on your calculator to close this again. Now, this particular calculator needs you to come out of it, out of the radical. So you have to put that arrow key and now you're out. And some of your calculators are like that, I guess. So now, guess what? We're done. We get to hit enter and we get a test statistic value. And I'm going to remind you, because this is a common question. People will ask, Mr. Judge, where do I approximate this to? So I'm going to ask you guys, where do we approximate this to? Anybody know? Where do you approximate that? I'm going to remind you of your critical value is 1.645. So where do we approximate this test statistic to? Anybody know? Because I wrote it down on the iPad. Thank you, Cassandra. Let me get my mouse out here. Cassandra's correct. And guess what? Leopoldo's correct. So they're both right because you always approximate your test statistic to the critical value, place value. So if the critical value is in the thousands position, yes, approximate this to the thousands. Absolutely. Okay, that's the idea. So now if you go back to the iPad, you might say, oh, okay, that's 2.707. And you're right. And you say, why does it have to be that case? Because remember, you're comparing, ladies and gentlemen, that any critical value that's less than, or I should say any test statistic less than your critical value, you do not reject the null. Any test statistic that's greater than the critical value, you reject the null. So if you're comparing here to the critical value of 1.645, to do a proper comparison, you compare it to the same decimal values. So this is 2.70, what do we say, 7. So that test statistic, ladies and gentlemen, 2.707 is to the right of this value. Here's where that goes. And more importantly, it's in the reject the null region. So stop right there. Reject the null. I write this down personally. I'll write down reject the null. However, on a test, I'm not going to give you credit for saying that, because that's analogous to saying I don't know the answer. Now remember, hypothesis testing is about you testing a hypothesis. And that's the foundation of our scientific method. So we're going to test the hypothesis here. We're rejecting the null. So I have to go back to the hypothesis setup. When you reject, ladies and gentlemen, you throw out. That's a rejection. It is out. And you say, what's out? The null. That premise is gone. It's rejected, thrown out. But then what's left if that's thrown out? Anybody know what's left? The alternate hypothesis is left. The statement that the proportion of women is greater than the proportion of men who pass. And that happens to be your claim. So the sample information supports the claim because that's what's left. All right. Sample information supports the claim. So the sample supports our claim. And yes, okay, we have Catherine, definitely. The sample supports the claim. And ladies and gentlemen, there it is. And there's a good hypothesis testing question that's not medical related, but a lot of them are, and I kind of like those medical questions. So, looking at something here. I'm going to try to find a good one here for you guys. Testing claims about a proportion. And yeah, I think I'm looking at the wrong. No wonder. Wrong chapter. I don't see two proportions. Okay, let's actually look at. I like kind of this one. Clinical trials of Oxycontin. I don't know what that is. Let me get rid of this. Sorry. Clinical trials of Oxycontin. I'm looking at the book, and I'm gonna have to paraphrase it because I don't want to write all this stuff down, and I don't want to plagiarize. Right. Clinical trials of Oxycontin. Oxycodone is a drug used to treat pain, but it is well known for its addictiveness and danger. So it's highly addictive, and I guess it's unhealthy, but it helps you with pain. So I guess they do it because it's a short-term sort of solution, but for some people it becomes long-term. In a clinical trial, In a clinical trial, I'm going to write that down. Among subjects treated with Oxycontin, I'm going to call it Oxy for short, 52 developed nausea, and 152 did not. Among other subjects given placebos. So others were given a placebo, ladies and gentlemen. So among other subjects given placebos, 5 developed nausea and 40 did not. Period. I'm going to say here, use the 1% level of significance to, let's see what this is. To test the claim that the nausea, sorry, it's very difficult to talk and write at the same time. That the nausea rates are not the same. So something like this is kind of a very, very good question here. And like I said, it really, if you read your book, I understand people say, boy, Mr. Judge, I kind of, I like kind of your examples. I like kind of the ones you put on the web. And then I read this book and I kind of lose it, right? Well, I always tell you guys, this book is very good because it is giving you information that you can put together. And then, conduct a hypothesis testing situation with and say, how do I know this is a hypothesis testing? Because they say, test the claim. And test the claim that what? That the nausea rates are not the same. Now, probably, I don't want to highlight everything, are not the same. The nausea rates for what? So here's a classic question. You're testing people who got oxy. So I'm going to say you got the proportion of oxy versus the proportion who got a very classic thing, a placebo, a sugar pill. Placebo, ladies and gentlemen, is, it's not the medication. So you're comparing two groups. One group who got the oxy and the other group who gets the placebo, okay? So you're testing for the nausea rates. Does it make them sick? Now, the claim is saying that the rates are not what? The same. So this is not equal. That's the claim. Okay, so a very classic thing. This is how they test everything. One group gets the medication, the other group does not. They get a placebo. They all think they're getting the medication. Anyway, here we go. We're going to set this up. H naught, H1. So PO for oxy is not the same as PP, that's placebo. And again, this is the researcher's claim. The opposite of the statement, PO equals PP. Now, that's not the claim. All right. And then you say to me, okay, what kind of tail is this? Or I should say, what kind of test is this? It's a two-tail test because that's not equal. So do not here reject the null. And over here, we reject the null. This is a two-tail test. You say, how do I know? Because whenever it is not equal, it's two tails. We just need to know the critical values. And then that's where the level of significance comes in, because they tell us here, use the 1% level of significance. Now, 1% means, like we said, alpha here is 1%. Well, 0.5% is in the right tail, and the other half is in the left tail, because half and a half is a whole. Now, 1/2 is 0.5. Now, we really care about this because that means we get 49.5% here. And also, by the way, 49.5% here. So this is going to help us find the critical value on that Z table, right? So this is kind of what we've been doing, working backwards. Remember that? Working backwards, 49.5. Okay, so we go to the Z table. And we need to look for 49.5% now. 49.5% is going to be, we got to find 49 point, oh, is it right here? Take a look. It would be over here. It's between 49 and 49.51. That's where 49.5 would be. And then I follow the arrow. Oh, they knew I was looking for it. Look at that. 49.5%. They knew we were looking for it. They're saying that the Z-score is 2.575. Oh, that's where it was, right in here. Let's get rid of this here so we can really see that. So we found that by looking for it on the table. And there it is. Okay, 2.575. Good. So here we go. We're going to say this here is going to be 2.575 minus 2.575. So any test statistic that lives, ladies and gentlemen, between the critical values, any test statistic, we do not reject the null. If you live outside of these critical values, meaning if you live here larger than 2.575, you reject the null. If it's smaller than that minus 2.5, you reject the null. So we need the test statistic. All right, let's write this down. It's the same test statistic, ladies and gentlemen. We're going to take the sample proportion from group 1 minus the sample proportion from group 2. We need that P squiggle, Q squiggle over N1 plus that P squiggle, Q squiggle over N2, and you take the square root of that. And again, the pooled proportion is a sum of the successes, and we have the sum here of the sample sizes. But we're going to have to do a little bit of reading here on this one. Okay, kind of like this one here. Okay, these are our formulas. We're going to have to take a sample, though. 2 samples. Now, I'm going to say something here that's very important for you. I'm going to call that sample 1, sample 2, because what happens at times is people want to know which one's the first sample, which one's the second sample. And I'll tell you, go back to how you wrote this all down. Because we described this, and this is extremely important. Oxy, Well, that's the first population, right? You got that here from oxy. So the oxy data, ladies and gentlemen, is what is the first sample, which means the placebo has to be by default the second sample. And you look at this and you go, oh yeah, it is placebo, placebo. You got to be consistent, and you got that here. So go back to the claim and how you originally wrote that down, right? Reading left to right is what we do. If you start reading opposite directions, you'll have a problem. Okay, so we need the oxy data. And you say, well, what is the oxy data? Well, what does it say? Subjects treated with Oxycontin, 52 developed nausea, and 152 did not. Now, this is going to be tricky, ladies and gentlemen. Here's what is going on. Could you guys tell me? What does that first number measure, and what does the second number measure? Anybody know? What's this about? This is about nausea rates, getting nauseous. Nausea rates. What do you guys think? If these are proportions, we need a success here. How many successes are they saying that we have? What do you guys think? How many successes are here? We have 52 successes. You say, how do I know? Because they just told you. 52 developed nausea. And then you say to me, well, what does the 152 mean? Well, what does it say? 152 did not develop nausea. So what's the sample size? 52 plus 152, which is 104. Oops. Sorry. You're right, Leopoldo. 204. It helps to know some arithmetic. Good. There you guys go. And that's what they're doing to you in this one. And so the next one works the same way. And you say, what do you mean? Yeah, they're saying the next one, 5 developed nausea and 40 did not develop nausea. So 5 is the number of successes for the placebo. So we say here, X here is 5, and then N is 5 plus 40, which is 45. And don't forget, 1, 1, 2, 2. So this is the information that we read that we have to use. So we got to plug this in here. So you say, oh, 52 here, 5. Yes. 204 here, and 45. Okay. We need sample proportions, so we need the definition. 52 out of 204, and that's going to be compared to 5 out of 45. Now, we're going to approximate these to the thousandths. So let's kind of go to the calculator and say, okay, TI, 52 divided by 204 is about 0.255. And then 5 divided by 45, here's going to be about 0.111. So that's like saying, by the way, about 25.5%, about almost 26% of people who take oxy are going to be nauseous based on the sample. And about 11% that people who took the sugar pill got nauseous. Interesting. And then we need the pooled proportion, which is going to give us here. Let's change that color. That's 57 out of, looks like it's 249, right? Because don't forget, what do? For the pooled proportion, you add the successes and you add the sample sizes. So 52 plus 5, 204 plus 45 is 249. We're going to approximate that to the nearest same decimal place. So, oops. Sorry, let me go back and show you on the iPad. Right, here's what I'm saying. The sum of the successes is 52 and 5. And the sum of the samples is 204 and 45. And that gives you 57 over 249. So we want to approximate that to the nearest thousandths, 57 divided by 249. And you get 0.229. That's your sample proportion. Now the complement of such, we take 1 minus that. So we're going to say Q hat, or squiggle, that's a squiggle. What's 1 minus this value? So let's go back to the TI. .771. So we're going to use these values here. 229.771. So go back up here. 229.771, 0.229.771. Remember your sample sizes. First one was 204, and the second one was 45 here. So we now have all the information we need. Let's look at the iPad. Right, we plugged everything in the appropriate spot. And then don't forget, when you plug this in your calculator, parentheses and a double parentheses on these locations. So we're gonna plug it in now. We're gonna use it this way, okay, for the sake of time. Or if you said, I kind of like that. I kind of like how you rewrite that. All right, okay, you twisted my arm. 0.255 minus 0.111. 0.229. 0.771. Over. Over. First sample size was 204. Second one was 45. Okay, we're gonna take a closer look at this here, and like I said, that's kind of always a good option. Okay, so let's plug this in our calculator. I'm gonna clear everything. So we say 0.255 minus 0.111. Close that. Divided by the square root. Second square root, double parentheses. We're going to say 0.229 times 0.771 divided by 204. And you close that and you add another set of parentheses. And you're going to say 0.229 times 0.771. You're going to divide that by 45, and you close that twice. Get out of the radical. Here's what you get. Double check that we're okay, right? And again, you always approximate to the place of your critical value. So the critical value is approximated to the nearest thousandths, which means your test statistic is 2.081. 2.081. And that's the nearest thousandths. So 2.081, ladies and gentlemen, let's see where that lives. All right, let's erase all this stuff. So 2.081, where is that going to be? That's going to be somewhere over here. Here's your test statistic. Since the test statistic lives between these critical values, we do not reject the null. So if you said, oh, Mr. Judge, is that my conclusion? And I'll say no. Sorry about that. Do not reject the null. So I go back to the null. Where are you, null? There you are. Do not reject the null. Say do not. What does it mean not to reject? You guys know what that means? Don't reject. Let me double check my work. Okay, double check to see we got the right critical value. So do not reject the null. What does that say? If you're not rejecting the null, you are accepting the null. And let's double check let's double check this here. I kind of have a kind of thing. I want to double check my work. 52 and 5, we got 0.229, 0.771. Okay. 204 and 45. So I'm gonna double check the test statistic value, ladies and gentlemen, just in case. Okay, so a lot of times when you talk and write, you it's not good. Get out from under that. And okay, looks like we're okay. Anyway, okay, let's go back. Looks like we're good. Okay, let's kind of talk about this. If we do not reject the null, right? We're not rejecting that null. That means we are accepting the null. What does that mean about the claim, right? What we are accepting is not the claim. So what this means is the sample does not support the claim. And this is the formal result of your test. The sample does not support the claim. Yes, exactly, Cassandra. Yes, that's true. The sample does not support your claim. Now, let's talk a little bit about this because it kind of seems odd, and that's why I had to double check my values. Well, here's kind of a little something I want to point out to people. If you go back up here, first of all, if I use a 1% level of significance, that's an extremely sensitive kind of tests, because we're going to talk about level of significance of your alpha. I'm going to give you some information about that as soon as we finish with some of these ideas. So, alpha is 1%. And so, yeah, ladies and gentlemen, it's very sensitive, of 1%. Now, what's less sensitive is 5%. What's even less sensitive is 10%. So, first of all, they gave it a very strict sort of sensitivity for this hypothesis testing test. The second thing I want to point out to people is that these samples, even though they're considered large samples, like this sample here is large, this sample's large. It's relatively small, the placebo sample. It's almost a small sample. So that's actually another factor in affecting this pooled proportion rate of 229. So, it's kind of, in my mind, it's a good study. This study suggests that the proportions of nausea are about the same, but it's only because you did a highly sensitive test and one of the populations was kind of small. Now, if they're both kind of small, that's still a little bit problematic. So I would continue with the study personally, and I would say I think I'd like to take larger samples for the placebo, larger samples for Oxycontin, and, we'll go from there. But, we went through the procedure for this. And my guess is, yeah, Oxycontin does make you nauseous, as you can see just by some of the sample proportions. But, we did a sensitive test with a small sample for the placebo, or smaller, or much, much smaller. I try to even it out a bit and see where things go. But anyway, you're right. And so if there's any questions on this, let me know. This is a good kind of question. And just wanted to double check to make sure all our work was okay. And it looks like it's fine. So I don't know. Anyway, let's look at the situation over here in our browser. So we go to this browser and we get to Math 227 and we say, what do we say? Look at this portion here. Statistics Lecture 14. So what you guys have now here for Statistics Lecture 14, I'd say, yeah, starting over here, the 15, 16, 17, 18, 19, 20 here. We got a comment here, a bit tricky. If the tails are going to be 0.05 or 0.5, well, be careful here. Wait. Did we make a mistake? Let me double check Leopoldo's comments. Ooh, let's double check the comment. Let's see. A bit tricky. If the tails are going to be 0.05. Now, 0.05 is 5%. Or 0.5 because of the 1%. It's 0.5. You see, Leopoldo, you take 1 and you divide it by 2. Now, 1 divided by 2 is 0.5. That's 0.5%. And then that will give us that 49.5%. So it's 0.5%, not 0.05%. Okay. Anyway, let's look at these questions here that you guys see. 15, 16, 17, 18, 19, 20. Good questions here. Look at the last sentence, because this is comparing proportions. The last sentence here in 15, at the 5% level of significance, they're saying, test the claim that the recognition rates are the same in both states. Being the same means equal. So P1 equals P2 in question 15. Now, in question 16, they just say, hey, they gave it to you. P1 is less than P2. So there's no real reading there, although you have to read an inequality. 17, test the claim that the proportions are equal. They're testing to see if they're the same again. Equal is the same as saying they are the same. So here, P1 equals P2 as your claim. 18. The proportion of men, I guess it's, test the claim right here. Test the claim that the proportion of women favoring stricter gun control is higher than the proportion of men who favor stricter gun control. So P women being higher is greater than P men. P women greater than P men. That's what question 18 is saying. So this is where people start to have an issue. How do you read this statement? So that's 18. P men is greater than P women, meaning they're saying that the proportion of men who, P women is higher than P men. That means the proportion of women who favor gun control is bigger, larger, higher, greater than the proportion of men. So let's look at 19. Let's look at what that statement says. Test the claim that the proportion of smokers from the two groups are the same. So I guess they're looking at people from different age groups who smoke. You know, they're saying that 20 to 24-year-olds have a smoking rate of 22%, and then 25 to 29-year-olds have a smoking rate of 14%. So they're trying to say, test the claim that these two groups have the same is equal. So P1 equals P2. So that's number 19. And number 20, it's a vaccine question. Oh, I like those. 7 out of 8,500 people vaccinated against a certain disease later developed the disease. 18 of 10,000 people vaccinated with a placebo later developed the disease. Test the claim. Right here. Test the claim that the vaccine is effective in lowering the incidence of disease. You go, Mr. Judge, what are they telling me in number 20? They're saying in number 20 that the probability with the vaccine is less than the probability with the placebo. Let me double check. Let's read it again. Test the claim that the vaccine is effective in lowering disease. You're vaccinated against the disease. So the P with vaccine has to be smaller than the P with the placebo, because they're saying it's against the disease. So you want that probability for people who actually get vaccinated, they want that to be lower than the probability of people who don't. So, vaccines, you may think, oh, they're going to stop you from getting something. No, vaccines don't necessarily stop you from it, but it lowers your chance significantly. Okay, so they're saying 7 out of the 8,500 people vaccinated against the disease later developed it. That's 7 people who got it. It didn't eliminate it. And over here, 18 out of 10,000 people got it, but they had the placebo, the sugar vaccine. And they later developed the disease. So test the claim that the vaccine is effective in lowering the incidence of the disease. So it's P vaccine less than P placebo. So what I did here is I went through the statements here for you guys on the web. I'm also looking at your book to say for some homework for you. Web, Statistics Lecture 14, book. You guys can do 9.1. Remember, I like these. Seven, 2, 21, odd. Anyway, let's go back to the iPad so you guys can see that. So here's your homework for this weekend, and I hope you guys get started as soon as you can, because, this stuff creeps up on you. And if I go back to the browser and say, okay, when's our next test? Because that's coming up for people. So let's go back to the browser, right? We have the last test in your final. So, okay, browser, let's do this, get small. Let's go back here. So we're going to go to your class here. You guys are 227. And we're going to go to your schedule. So if we look at this document, I guess we can't get there. Okay, look at the bottom here. It looks like Monday, June 1st is your test. So I'm giving you guys some time here to work on these things. So next week we're going to do a few things, and so make sure test 4 on June 1st we have. I'm going to remind you guys to make sure that you know how to do some things. First of all, we're getting down to the end of the semester. So you have test 4 on June 1st, that Monday, and then you have your final on June 4th. So I'm going to try to get some information up for you guys as soon as possible. A couple of things you guys want to do, though. You got to make sure you know how to scan. Okay? You say, what do you mean, Mr. Judge? Yeah, when you scan, I mean, when you guys take pictures and you upload them to Instagram, social media, do you upload blurry pictures? Are you guys doing that? Because I've never seen that on social media. So you should know you don't send in things that are completely blurry that you can't read. That's suspicious. So number one, make sure you guys can scan appropriately and that you know how to upload them and you batch scan it. Don't send, and supposed to, we accept PDF files. Don't send JPEGs. You have to send it as a PDF. And make sure that, you upload it to the right place. All those things are factors. And so you have to know that you are consistent and functional with how to upload, because that's how you take your test. So that's another thing. Make sure you keep track of your time. You don't turn your test in when ultimately you get a chance to, or when you get around to it, right? You got a test, it's timed. So you're going to have that barrier too. So make sure you time it and you upload it to the right places at the right time. And that's how we do things. So you get an opportunity on June 1st, and then you get another opportunity on June 4th. So hopefully there's no hiccups. So by now, people should be good. Now, if you say, I need to practice that stuff, then practice. Practice sending your friends things, right? Scan your homework to your friends and send them to your friends, because once we close the books are closed. And that includes scanning your homework. And your homework is due when it's due, not when you get around to it. So, make sure you follow those deadlines. And I'll post this online when we get to the dates. And like I said, your homework's due not the day. It's due before your exams. So before your exams, like this were class, you guys remember, you come in, you turn your homework in, and then you get started on your test. Nothing's different. Day of your test, submit your homework, then you get started on your test. So some people in my classes, they actually submit their homework way before, really. They submit it the weekend of. And then some people are busy trying to submit homework now, still. And you're like, really? I think you missed the deadline. You guys know what I mean? So make sure you can, do these things and you go by your, your deadlines. Follow the instructions. So I'm going to send you those instructions. Follow them. Also, you're going to have a study guide for your test 4, and you have a study guide for your final. So, if you guys want to do this, do it that way. You can. And, you should be doing it that way. But this is where we're getting to. This is getting down to the very end. And what happens sometimes when people get down to the very end, they start to realize they ran out of time, right? They go, oh, I thought I had more time. Oh, I don't think I ever studied. Oh my God. Oh, I'm. So what happens is they start to panic, and they want to submit all of that anxiety to their instructors, right? They want to transfer that. And it's like, sorry, no anxiety coming here. So remember, I'll give you study guides. Make sure you do the homework that we assign and you work on that. This is about you. It really comes down to following processes and instructions and really reading and comprehension, because the math part is really, you haven't really done any real arithmetic. The calculator's done that. So it really comes down to, when I measure, if I said, who succeeds and who doesn't, it comes down to functionality, and who's able to follow the instructions and put things in the right places at the right time. That's what it comes down to. And for all of us, it's an adaptation. We have to adapt to that. We have to grow. We have to realize that, oh, these things are done this way, and we transition. And some people can't, and some people can. So you're kind of transitioning. Don't take a look at it in that way. It's a transitional period for you, and hopefully you guys can transition enough to move on. And that's where it's at. So, ladies and gentlemen, again, I'm giving you sort of the story of what goes on at the very end. And we got a comment. The scanning in time is a little stressful. Yeah, I know. Probably because in a class setting, you have somebody reminding you, you got 5 minutes, right? You got 10 minutes. You got 1 minute, please. And you do have that reminder. So I would even say put your alarm in some ways. Put your alarm for your stuff. But, you do have to, there is a sort of thing that, that you guys don't realize that's discussed right now in this area, which is academic integrity. And that it's related to accreditation issues, valid grades, valid certificates. It's really a big statewide deal and really national deal. That this kind of situation is opening the door to some very things that people are saying, hey, you got to be careful. So you got to really be careful about the academic integrity of everything. And, there's a story from another instructor that a student scanned their test, right? And they only scanned the cover sheet, thinking that the scanning software scanned all the pages underneath. So what I'm saying is, make sure then, Cassandra or anyone else, that you're good with scanning, even if it means you have to practice something simple like scanning something and submitting it. Because what's going to happen here is people are going to do some things without a doubt. They're going to try. And that's the integrity that we have to look out for so we can prevent any real serious, accreditation issues with the courses and everything we do. So it's a lot more serious than people think. People think, hey, what's the difference, Mr. Judge? I was like, no, it's an integrity issue that the state looks at. And there's all kinds of arguments throughout the state about some of these things, whether courses should be even offered because there's no integrity. So it really is more serious. And then we have here, Catherine Molina, I scan my homework a night before. The day of the exam, I submit it, and it saves me a lot of time. Catherine, this is what I'm saying. There are people who definitely do this. They scan it. They do it that night before. They get their formula sheet the night before. They're functional in that way. This is how you got to do it. This is how you have to be. Other people will say, I'm going to work on the homework the night before. I'm not going to sleep the day of the test or the final. So I'm up all night long doing my homework, and I panic because then I have to scan it, and I forgot to scan it, and all these things. So those are factors. Now, this is not really, I'm not talking about the technical factors, because there can be some technical factors. I'm talking about the functional factors. So yeah, what you should do, if it were me, and when I was a student, my homework was done and ready and stapled to get turned in before class, because you have to focus on the class and the test. So I wasn't going to use that time right before class to try to find a stapler and put things together. And I mean, I've had people the day of the test, I mean, it's something I'll talk about, who they'll get everything out and none of their homework is like together. It's in one book. It's in another book. I've had people sit on the floor, empty out their backpacks, simply trying to put on the floor all their test homework together and staple it. And they don't even know the order. And that's what I'm saying. This is what I noticed. This is not about academic ability. It's about functionality. Did you think of putting things together, before your test, hopefully? Did you think of submitting that type, So it's the same thing remotely. You scan your homework the night before, the exam, and just submit it, and it saves me a lot of time. Yeah, you can even submit it the night before since this is up 24/7. So that's the kind of little things I say to people that will help you with the anxiety of what you're doing, even in this environment, is to make sure you gather the things you need to be successful. Even if, and like I've said, as you do your homework, write down your formulas. Because you're going to use your formula sheet. I'm going to have people ask me. They're going to say, hey, can you give me the formula sheet? I'm like, The formula sheet I'll give you is the one I have on my website. Oh, but I don't like that one. Well, then make your own. We're allowing you to make your own in this transition. This is not something I've usually allowed even. But, since you're already there home, make your own formula sheet. If you like the formula versions I give, then okay. Then you write those down because you're going to need them. And when do you do it? It's not the morning of your final. You do it now. You're getting ready now for the end of the semester because this is your life. This is you moving on. And if you value those things, you're going to follow what I say. Not because I order you to have some master-servant relationship, right? It's because you care about what you're doing and you want to be successful. So there's a lot of little things that you should be doing to get ready, even now. And there's even more of a responsibility, because of the fact that this is remotely done now. So make sure you guys have that stuff in order to help yourself. So the test is on June 4th. Well, we're going to be clear, Paula. Let's go back. Test 4 is on June 1st. The lower right-hand corner over here, where you can see that. Test 4 is June 1st. Final is June 4th. Final exam, June 4th. Okay, and it's at these times. So make sure you guys are clear with these things. You're going to have a test 4, and then you're going to have a final exam. All right, and anyway, so that's what's happening here with us. So you guys know. So make sure you guys are good to go, and those are the little details. You have your homework assigned, and then sometimes people will say, "Hey, let's go back to the browser." I go, "We're in the browser." If you go to that website there, even if you said, "I kind of don't like any of the stuff you did this time with the lecture," well, guess what? I did videotape those lectures. As you guys can see, Statistics Lecture 14, we talked about that. 3 hours long. There I am. Oh, let's get rid of this. There I am, and that was, I guess, in 2008, or I don't know. Whatever. I'm going through these, comparing two parameters, really. Comparing two proportions and compare two means. And this is where we're at, kind of. So, and even if you got stuck on some of the odd number, on some of the questions, look at the odds. I have video solutions for the odds.
The null
Here's 13.
is greater than or equal to 14. The alternate is less than 14.
Now, this is technology, from 8 years ago. Compare that to the iPad. So I did this for you guys all along, and there's only 2 likes. 570 views, but only 2 likes. And this helps save your life, ladies and gentlemen. This is only 2 likes? Are you serious? And well, I guess I put it up. What did I do? Oh, I know what it is. It was in 2016. I had to upload this to YouTube. It was on it was on a streaming server from the school. So anyway, but still, since 2016, in 4 years, there's only 2 likes. Okay. I would like it, like I said, years ago, you couldn't find an instructor in office hours. They weren't even necessarily there. Now you have all these resources, and I wish back then I would have had them. But I went through an hour and 45 minutes of solutions here for you guys for hypothesis testing for about half your homework. So if there's any issues and concerns you guys have while you do your homework, the idea was you have this available 24 hours a day, 7 days a week. So you have some resources, and now there's additional resources in the sense that we went to the online transition, and those are on YouTube, these lectures. So anyway, ladies and gentlemen, there's my lecture. And even if you said, well, I didn't pass any of my tests. Well, if you pass your final, you pass the class, because the final is comprehensive, and passing is at least with a C. So, make sure you start putting those things together for yourself. Because at the end of the day, when the doors are closed, I add the points, submit the grades, I move on, and we all move on. Okay, so make sure you guys are starting to prepare for that, because I'm starting to prepare for it. I'm going to start working on a study guide for your test 4 and a study guide for your final exam. And I'll try to post that up as soon as I can, hopefully this weekend even. So you don't have a lot of time, so I'm going to try to take advantage of the Memorial Day to get you guys some extra time to work on what you need to, not for me, but for yourself, and then, Hopefully the results are good and we all move on. So anyway, if you have any questions or concerns, I'll be in my office for office hours. I sent you guys a link to that already. So, just click on that and I'll be there. What I did was I merged 2 classes together, or all the classes together. So that it's, a lot more, it's easier to do for everybody. So take care, stay safe, stay out of trouble in the sense that you're home studying. Okay? All right. Take it easy, and I'll see you guys later.